In this video, we shall understand the need for modulation. Okay, so what do you mean by need for modulation? What do you mean by modulation? Modulation is a very simple process that changing the characteristics of the carrier wave according to the instantaneous values of the modulating signal is what we call it as modulation, right? So why this modulation is required is what we are going to discuss in this video. So the very first point what he says is, for long distance communication we require modulation. For long distance communication means sending the baseband signals. To send the baseband signals over long distance, modulation is necessary. What do you mean by the baseband signals? Baseband signals are those signals which have lower range of frequencies. When these signals which are having lesser frequency are made to travel through a longer distance, they are very much affected by the interference or noise. So to avoid the effect of noise and interference, we have to modulate the given signals for transmitting them longer distance. Okay, to transmit the baseband signals over long distance, we require modulation. Modulation is to be done. Next point that we are going to discuss is for ease of radiation. What do you mean by for ease of radiation? Designing the antenna, whatever that you are able to observe here in this picture, designing that antenna is a difficult task for an engineer. Okay, so these dimensions of antenna dimensions, okay, these dimensions of antenna are the multiples of, okay, the dimensions of antenna are the multiples of wavelength. Okay, the dimensions of antenna are the multiples of wavelength. That is why if I have lesser wavelength, the antenna dimensions are also going to reduce. Okay, as this happens, the designing the antenna becomes easy. So that is why for ease of radiation, the modulation is necessary. So in modulation process, we know that, right? So the modulating signal is always going to have lesser frequency and the carrier wave is going to have higher frequency. When we have higher frequency for the carrier wave, the wavelength is going to reduce. When we are going to reduce the wavelength, the antenna dimensions also going to reduce. This is why for ease of radiation, the modulation is required. So when modulation is done in higher frequency, it reduces the dimensions of antenna. Okay, when modulation is done in higher frequency, it reduces the length of the antenna. Okay, so this is what happens. For this reason, we need modulation to be done. For multiplexing, what do you mean by multiplexing? Multiplexing is a very simple concept. Just by seeing this diagram you can understand. So I have signals like this. Okay, signal number 1, signal number 2 and signal number 3. Okay, I have 3 signals. All these 3 signals should be sent to the destination. This is source and this is your destination. Okay, so all these 3 signals should be sent to the destination through a single communication channel. Okay, we have only one communication channel and we have to send all these 3 signals through the single communication channel. Then we use a concept that is called as multiplexing. What we do, we put signal 1, signal 2 and signal 3 all in the one composite signal. We make composite signal by using signal 1, signal 2 and signal 3, and that composite signal is made to move from, or is made to transmit from source to, this is source and this is destination, source to destination. Okay, so such a concept is what I call it as multiplexing. Okay, multiplexing is that adding number of signals together, making it into one composite signal and making it to move from source to destination is what I call it as multiplexing. To make the multiplexing achievable, modulation is required. Okay, so when I add these three signals and make it into a composite signal, it is very likely that these three signals may interfere each other. These three signals may interfere each other. To avoid the interference, we need to modulate these three signals with the carrier frequency 1, carrier frequency 2 and carrier frequency 3. When we do that modulation by using carrier frequency 1, 2 and 3, what happens? The signals will be, the modulating signals will be put into different carrier signals. When we have put the modulating signals into different carrier signals and then we add these three signals into one channel and make it a composite signal, then it will be transmitted from source to destination. At this situation, when we have done it, when we have done the modulation and then made a multiplexing, the signals are not going to interfere. This is the advantage of modulation in multiplexing. For multiplexing also modulation is required. So then I go to one more important point, that is, okay, fourth one. So what it says here, for frequency assignment, we require modulation to be done. What do you mean by frequency assignment? Frequency assignment is done to avoid the interferences. Okay, what it says here, frequency assignment is done to avoid the interferences. What do you mean by interference? Interference is that if I have a waveform like this, if I have a wave and if I have one more wave which are moving in the same direction, okay, which are moving in opposite direction or same direction, when they meet each other, there will be some disturbances in the waves. That is why, that is what we call it as interference. When two waves meet together or meet opposite to each other, they may get disturbed. So that disturbance caused is what we call it as interference of the waves. To avoid that interference, we are going to assign the frequencies. Let me give you one more example and explain this. So let us go to our example of radio waves. Okay, so all of you people are very well versed or very well known with the radio usage of radio transmitter, right, or radio receiver. So we have different channels. For different radio channels will have different frequencies on which they will be working. Okay, they will have different frequencies. Such frequencies can be assigned to channel 1, channel 2 and channel 3 for simplicity, so that it becomes easy for us to listen to the channel 1 at a particular frequency and channel 2 at another particular frequency. To the channel 3 we can listen at another particular frequency. Okay, so this is why frequency assignment becomes easy. How to assign the frequencies? All the frequencies of modulating signal will be same, because voice will have same frequency. Okay, the thing that we are going to listen in channel 1 is voice, channel 2 is also voice, channel 3 is also voice, but all those voice signals will be having same frequency. So how to change the frequency range? We can change the frequency range, or we can assign the frequency by doing modulation. If I change the carrier frequency and modulate the three signals, though the three signals are voice signals, same signals, we can change the frequency. We can assign the range of the frequency. By assigning the range of the frequency, we can do the frequency assignment. For that also we need modulation. Then I come down to the next fifth point. So that is what I call it as for reducing noise and interference. What he says about reducing noise and interference? Interference can be minimized. By using modulation. So when I do modulation, there will be no greater effect of interference and noise on the signal. That is what I am going to explain in using this picture. Okay, in this picture you can observe that this is the sine wave we have, right? So this is the sine wave. So this is a modulating signal or information signal or important signal. So here you can observe that, okay, you have something disturbing signal, right? So that disturbing signal is what I call it as noise. Any unwanted signal is what I call it as noise signal. So when I do modulation on the information signal, it will have a protection against noise. Okay, noise can be avoided by using modulation. When I modulate the information signal with a carrier signal, so then what happens, the noise and interference can be avoided. So that is what he says in the fifth point of need of modulation. Okay, so then we go to understand one more small point, one more important point. So that is what we call it as sixth one. What is that? That is to overcome the equipment limitations. In most of the applications, what he says, in most of the applications, the frequency range of the processing equipment, and the signals does not match. Okay, the frequency of the processing equipment and the signals does not match. When they do not match, then what happens? Then as equipment frequency is fixed, the signal frequency can be changed, or signal frequency is to be changed. Consider if I have an equipment works at a certain frequency range. Okay, and the signal that is to be working with this equipment is at a different frequency. This is f2 and if this is f1. Okay, they both are under different frequency. We cannot change the frequency range of the equipment. That is a limitation of the equipment. To overcome the limitation of the equipment, we can change the frequency of the signal by modulating this signal to one more frequency, f3, wherein this f3 is equal to f1. f3 is very similar to that of f1. What is f1? f1 is the frequency of the equipment. So that is why to overcome the equipment limitations also, we can make use of modulation. And this is what the need for modulation 6 points conclude towards. So we need modulation for all these 6 scenarios. Thank you.